The overall goal of this procedure is to manipulate vortices in thin superconducting films by local vertical stress without applying current or magnetic field.
The ability to control the position of individual vortices is necessary in order to study how vortices interact with each other, with the material, and with other magnetic objects.
The main advantage of this technique is that it is a local method which allows very effective manipulation of an individual vortex with no additional fabrication steps.
We first witnessed the effect of strain on submicron ferromagnetic objects when we used SQUID to image and examine the way they changed their orientation as a result of stress.
Following this study, we wanted to investigate the effect of local stress on other nanomagnetic objects, and the first system we tested is a system of vortices in a superconductor.
First, prepare a thin superconducting film sample. Then, obtain a SQUID sensor fabricated on a silicon chip. Gently polish the chip with non-magnetic polishing paper to form a symmetrical point containing the sensing area. The material must be polished all the way down to expose the sensing area. Glue a flexible cantilever to a conducting plate with a dielectric layer. Then, glue the sensor chip to the cantilever. Mount the sample with varnish or silver paste. Then, attach it to the Z-axis piezo element. Set up 2 telescopes on translation stages and connect the telescopes to a computer via a camera. Connect the stick-slip coarse motion system controller. Direct the telescopes at the front and side of the